Good day, guys. Okay, so in the previous video, I've mentioned that in part 2, I want to look at types of collision, and generally there are three cases. Number one is elastic, second is inelastic, and the third is explosion. All right. However, there are only two types. All right, of collision. Number one is elastic. So in the case of elastic collisions, generally, or you characterize it with the obeyance of momentum conservation and the obeyance to the conservation of kinetic energy. So that means your kinetic energy final will be the same as your kinetic energy initial. All right. Now, for inelastic, they still obey conservation of momentum. However, they do not obey conservation of kinetic energy. So that means your final kinetic energy is not going to be the same as your initial kinetic energy. Now, I've mentioned three cases: elastic, inelastic, and explosion. But I did not write explosion in the types of collision. And the reason for that is explosion is merely a case for the inelastic collision. And here's the argument for it, right? So for collision, you start with both of the items, the simplest example, at total velocity to be 0. Okay, and then what you do is you provide a hit or an explosion, right? So that they move apart from each other, or they move in the opposite direction. So the first one goes to the left, the second one goes to the right. Okay, and now this one will have its own velocity, so I'm going to call that VA, and this is going to be VB. Now, momentum is still conserved. However, we have to remember that kinetic energy is equals to half mv square. And because there is a square contribution there, for the final kinetic energy, final total kinetic energy, right, will be bigger than the initial kinetic energy. So for explosion, the case is that EKF will be bigger than EKI. And it makes sense because the kinetic energy for the final is provided by us hitting it or the explosion that happens. So it changes from, for example, if you use a bomb, right? If you use a bomb, then the chemical change in that bomb provided the moving bodies with kinetic energy. You convert the chemical energy to kinetic energy. So in essence, the kinetic energy is not conserved. If it's not conserved, we can categorize it in the inelastic case. All right, I hope that is clear. Okay, I'm not saying that explosion does not happen. I'm saying that explosion can be categorized into the inelastic collision type. Okay, so there's only two types, elastic and inelastic, and an explosion is a special case for inelastic collision. All right, so let's summarize. Okay, for both the elastic and inelastic collisions, they both conserve momentum before and after the collision. However, whilst the elastic collisions conserve kinetic energy, the case for inelastic collisions does not. Okay, so your final kinetic energy will not be the same as your initial. Okay, so I hope that summarizes for you. So that is the end of chapter 3. The next video is going to be chapter 4, where we talk about Newton's law of motion. All right, so that is all for this chapter. I'll see you in the next chapter. Thank you very much.